Hi kids, happy Euler method day. Today we're going to talk about how to approximate differential equation solutions numerically. So with numbers, we've done it algebraically with separate and integrate. I feel the need to write this down. Algebraically. This one you can find like the actual real answer if you separate and integrate, but that only applies to separable differential equations. We've got a graphical approximation using slope fields. So we can do it algebraically, we can do it graphically. Again, this is an approximation. And then finally, your last way to look at these things is numerically through this wonderful process called Euler's method. Euler's method is an algorithm, which means a formula. It's another approximation technique, and it's super easy. So here's what it does. Let me explain it to you first. Let's all make believe that you have a differential equation that looks like this. It's my favorite one. That's why we keep doing it. So this differential equation, I'm going to have a start. Y is 0 equals 1. So I have to give you a starting point. And then your instructions are going to look like approximate. And you never have to guess. They'll say approximate using Euler's method. Approximate y of 1 using 2 steps. Again, you never have to guess. They're always going to give you all of this information. So here's what you're doing. We are going to start where they tell us to start because we're not monsters. So here we are at 0, 1. So at this point 0, 1, the slope of our tangent line, if it equals y, our slope of our tangent line is 1. So they are having us walk along these tangent lines until we get to the number we're trying to approximate. So they want us to approximate 1, and they want us to use 2 steps, which means we're going to stop at a half and reevaluate and then go again to get to 1. So I'm starting here at 0, 1, and I'm going to leave this point in a linear fashion with a slope of 1. So I'm going to leave with a slope of 1, but I'm going to stop when I get here. So this thing has a slope of 1. So if I've left with a slope of 1, but I only moved half a block, half of a grid distance, now I'm sitting here at a half, comma, what? Well, the answer is 1.5 because I started with a y value of 1. I moved with a slope of 1, so now I'm at a half. All right, so now I'm going to leave this dot, but I'm going to leave this dot with a slope of, so if dy dx is y, I'm going to leave with a slope of 3 halves. So that is going to be a little bit steeper. And now I'm going to stop here. And the goal is to figure out where are we. So I left with a slope of 3 halves. I was already at 3 halves, but I only moved half of a block. We're at 9/4. Just trust me. I'll show you the algorithm. So what you're saying here is that y1 is approximately equal to 9/4. Now we've done this differential equation, I think, about 3 times. The only curve in the whole wide world that you take a derivative of and get itself is e to the x. So this function is e to the x. I did it on purpose. And if I start you at 0, 1, it literally is just e to the x. There's no shifting involved. So what I just asked you to find, or approximate, I guess, was e to the 1, which we all know is 2.7-ish. Well, we got 2.25. So good job, us. That's an okay approximation. Not great, but it's okay. How do I make it better? I take more steps. So let me take more steps, but let me do it showing you the algorithm. So this is just like what we're doing. Now let me show you how to do. You were going to do Euler's method. Let's pick a new curve or a new differential equation, I mean, because they can be anything, but I should probably pick one that I've already written down. Let's do x over y plus 2. We're going to start at 0, 1, and I would like to approximate y of 2 with 2 steps. Okay, we are going to do, our class, if you look other places, you're not going to see this, so pay attention. We're going to use a table because it helps us organize. Our table is going to have 3 columns, y values, x values, not in that order, and change in y values. Okay, so let's think about what we can fill in already. I know my x's start at 0 and my y starts at 1 because that was given. I know that I need to get to x's 2 and I need to do it in 2 steps. So there's 1 step, 2 step. Got it. I don't know my new y values, but I also know this column. So everything I do is coming from this differential equation. If I rearrange, I can solve for dy. dy is x over y plus 2 times dx. Okay, remembering what dx stands for, it stands for change in x. Dx for this problem, if I'm going from 0 to 1 to 2, then dx is 1. So I'm going to fill in this column using x over y plus 2. I'm going to write times 1 so you know it doesn't just disappear, but dx is 1 for this problem. It's not always 1. All right, so now I work up my way across. So when I'm at the point 0, 1, the change in y, dy, is x, which is 0, y, which is 1 plus 2 times 1, so 0 over 3 is 0. Okay, fine, no problem. So that means that as I leave this point, 0, 1, I leave with a slope of 1. I'm sorry, I leave with my change in y's of 1. That means when I leave this point 0, 1, my y values are changing by 0. So if I'm at 1 and I change by 0, I'm still at 1. No big deal. Let's do again. So now we have a new x and y value to plug in. It's just a rinse and repeat. So now dy equals x, which is now 1. Y is still 1. That equals a third. So now we're going to leave when our y values are going to change by a third. So our y values were 1. They changed by a third, and now they are 4 thirds. So this is your answer. Don't go again. That tells me that you don't know what's going on. So you're telling me that the point 2, 4 thirds is our approximation using this differential equation in that curve. 3, 2, 1. That's really it, kids. I'm going to make another one, and I'll magic pop an answer up here for you so you can pause it and give it a shot. Because I'm making it up, it could be really phenomenal. You just never know what's going to happen. We're going to start this thing at y of, let's just start at the point 0.02. And I didn't mean that. I meant 20. I thought it as I was writing it, and then I wrote it backwards. And I would like for us to approximate y of 3 with 2 steps. We're just going to do 2 steps. It doesn't make it any harder doing more steps. You just have to do more iterations. So, all right, pause your video, give it a shot. All right, there's mine. I hope it matches yours. No promises, though. If you used decimals, then you're a monster and you have no friends. All right, let me know if you need anything other than friends. I'm not helping with that.